So in the previous session, we have discussed about different IT grades. So in this table, you can see, as per Indian standard, IT lowest IT grade, that is IT 01, and we reach up to IT 18. So total 20 IT grades are there as per Indian standard. Each IT grade that represents particular manufacturing process. So if you take example of IT 7, then IT 7 is for high quality turning, broaching and boring operation. Means if you do turning, then you get dimensional accuracy of grade IT 7. And if I'm getting dimensional accuracy of IT 7 grade, then what is the tolerance value? So IT 7 is equals to 16 times small I. Okay, where I is tolerance factor. We have also seen in previous session equation for tolerance factor. So this is about different IT grades as per manufacturing process. Today in this session, in this video, we will solve one problem, one practical problem to calculate tolerance or to define tolerance on manufacturing of any component. So that will give you more clarity. Then same equations, they are indicated in graphical form from IT 1 to IT 16. Different curves are indicated here as per the basic size. X-axis is basic size and y-axis is tolerance. So each IT grade, as I told you, that defines tolerance value in micron. So as you move from IT 7 to IT 16, more and more coarse tolerance or more and more rough finishing operations. Yeah. Then we are talking about this tolerance factor. So as I told you, different IT grades equations, they are given in terms of tolerance factor. So tolerance factor equations are given, but here two equations are given for tolerance factor. If your basic size is below 500, then we need to use this equation of tolerance factor small I, and if basic size that is in range of 500 to 3150, then we need to use this equation, capital I equation, as a tolerance factor. Now in this tolerance factor, you are having one another variable which is capital D. So capital D is equals to square root of product between D1 and D2. Now what is this D1 and D2? Basic size, different step size are defined. So you need to find in which step size basic size is resting. For example, if basic size is 45 mm, then you can see here as per general case 45 mm is in step of 30 to 50 mm. So D1 would be 30 and D2 would be 50. So in that way you need to find out D1 and D2. You need to select D1 and D2. You need to solve this. You need to find out geometric mean of diameter. You get capital D. Put capital D equation in the tolerance factor equation. That will give you tolerance factor value. And now we know different tolerance grade equations, they are given in terms of tolerance factor. So using those IT grade equation, you can find out tolerance value. But as I told you in previous session also, you need to take care, because when this diameter range is given in mm, so as you solve this capital D, you get value in mm. When you use equation of tolerance factor, you need to put capital D value in mm and you need to solve it. Whatever the numeric value you are getting as a solution of this equation, that value is in micron. Please take care of this. You need to put capital D value in mm. You need to solve equation of tolerance factor. Then the value of tolerance factor equation, that is by default, you need to consider in micron, because unit conversion is already considered in this equation. Okay, so I hope you understood. These are the equations, summarized form. So IT 5 to IT 16, 7 times I, 10 times I, up to 1000 times I, and equation of small I is given here. These equations we will be using today to solve one problem. We are also discuss about how to define tolerance or how to give define tolerance to any component. So two ways are there, unilateral and bilateral. So unilateral means we have understood this in previous video. If you are not able to remember it, then I request you to refer our previous video. Then unilateral and bilateral, two ways are there. What is unilateral? If you are putting entire tolerance zone on one side of basic size, either on positive side or on negative side, then that is called as a unilateral. If you are putting entire tolerance zone on positive side, then that is called as a positive unilateral. If you are putting entire tolerance zone on negative side of basic size, then that is called as a negative unilateral. Similarly, bilateral means you are putting your tolerance zones such that it is split on both the side of basic size, then that is called as a bilateral. But equal bilateral and unibilateral means you are putting your tolerance zone such that it is equally split on both the side of basic side, on positive side and negative side equally, then that is called as a equal bilateral. If it is unequal on both the side, then that is called as an unequal bilateral. So till this we have discussed in previous video, in previous session. Now we will try to find out tolerance for shaft manufacturing with basic size 70 mm. So what is data? If shaft of basic size 70 is to be manufactured from bar of 75 mm diameter using turning operation. So we are having raw material, we are having one bar of 75 mm diameter, we need to do turning of it and we need to reduce diameter from 75 mm to 70 mm. Now further, if lathe turning operation follows tolerance grade IT7, see we have discussed different IT grades are given as per the type of manufacturing process. So if you refer our the table which we have discussed in previous session, in the previous video, you find IT7 represents turning operation. Yeah, so IT7 grade is defined as a manufacturing grade of this shaft, then suggest tolerance value for permissible variation in the manufacturing dimension. So we need to find out tolerance value as per IT7 grade. When basic size 70 mm lies in step of 50 to 80 mm. So you remember this table, general case and special case. So 70 mm, that is in range of 50 to 80. You can clearly see here 50 to 80. So we are following general case. If you are following special case, since 75 mm, that is in range of 65 to 80. Please take care. So here it is already recommended follow general case. So you need to follow 50 to 80 step size. So capital D1 would be 50 and capital D2 would be 80 as per the general case. After that, different tolerance grade equation. So here different tolerance grade equations are given. We need to go for IT7. So you can see here IT7 equation is 16 times tolerance factor small I, and equation of tolerance factor is given here. It's a 0.45 times cube root plus 0.001 capital D. So we'll be using this equation to solve this problem. Now let's go to solution. So basic size is 70 mm, which is in step of 50 to 80 mm. So that's why capital D is equals to 50 and capital D2 is equals to 80. Now turning operation is following IT7 grade. We know equation of IT7 from previous table. IT7 equation is 69. So here IT7 is equals to 16 times tolerance factor small I. We also know equation of tolerance factor. So this is equation of tolerance factor. Now let's solve this. So we know capital D and capital D2, capital D1 and capital D2. So let's find out geometric mean of basic size. So capital D is equals to square root of product between 50 and 80. Then we get 63.25 mm. Now 63.25 mm we have to put in the equation of tolerance factor small I. So we are putting this value in mm in equation of small I and we'll solve this. Then we get this numeric value. But as I told you, by default this value is in micro. Now we know equation of IT7, it is 16 times small I. So now let's put this value of small I in IT7 equation, then product between 16 into 4.0476, that comes to 64.761 micron, and then this is what our tolerance which we need to give on the shaft manufacturing. This much of variation we need to allow. So tolerance is equals to 0.0648 mm. I have converted micron unit into mm. So we need to divide this by 1000. Then we get this value in m. So I hope you understood solution of this problem. You can use some other data, you can use some reference book and try to find out more solutions of similar problem. In next session, we will be discussing about deviations. So today we end our session here.